All right, so let's test our intelligence here. How can we find a sine and cosine equation given a graph? Which we did have an example like this before, but now we're gonna do several of them. So here's my graph. What I'd like you guys to do is I'd like you to find both a sine and a cosine equation for this graph. Hint, it's the same hint I gave you guys last time, is still identify the same things as before, right? Vertical shift, amplitude, period. Those three things are really going to help you determine those equations, okay? So go ahead, put me on pause, and let's check your work. All right, so let's check our work here. So we have a vertical shift of 0. The amplitude is 2, right? It goes from -2 to 2. The period is 2 pi, which would imply then that b is 1. So for my sine equation, it would be y equals sine of 2x, and y equals 2 cosine of x minus pi over 2. I can also kind of see here, if this was a cosine graph, like, starting at 0, it would have started here. So how did it shift? It shifted to the right, pi over 2. All right, so next example, same thing here. I would identify what's given and then go ahead and write your two equations, both as a sine and cosine graph. Go ahead and put me on pause. Okay, notice here that we have a vertical shift at -1 of -1. Our amplitude is 3, and the period here is again 2 pi, which once again means that b would have to be 1. So I have 3 sine of x minus 1, and also 3 cosine of x minus pi over 2 minus 1. That one shouldn't have been too bad. All right, next one for you guys to try. All right, so our vertical shift is 0, amplitude here is 1, the period is pi, it's kind of the big change here, which means that b is 2. So now you have to have 2 multiplied to x in the sine equation, and then same thing in cosine, and notice here that I have x minus pi fourths. If you had cosine of 2x minus pi halves, that would also be totally fine, like had you distributed the 2. But just know that this is affected because of our period. Next example. Again, go ahead and put me on pause. All right, so we have a vertical shift of -1, amplitude is 3, the period is 4 pi, which means that b is going to be 1/2. So that means 1/2 needs to be multiplied inside to the x values, so sine of x over 2. I have a 3 multiplied in front for the amplitude, the -1 for the vertical shift of going down 1. For the cosine graph, notice here now, you could have written this as 1/2 x minus pi halves, or just 1/2 quantity x minus pi. Where does that come from, that horizontal shift? Well, look at this point here. It shifted over to pi. All right, let's have you guys try this one. Go ahead and put me on pause. Okay, so we have a vertical shift of 1, goes up 1 this time. The amplitude is 2. The period is 2 pi over 3, which would imply that b is 3 this time. So for the sine graph, that's 2 sine of 3x plus 1. Cosine is 2 cosine 3x minus pi over 6 plus 1. Now, let's say maybe you weren't sure that this was at pi over 6. How could you figure it out otherwise? Well, let's take our period, which is 2 pi over 3, and divide it into fourths, which gives me pi over 6. Boom. Okay, next example here. Let's have you guys try this one on your own. Hopefully you're kicking butt. All right, we had a vertical shift of -1. The amplitude was 1. Period was 2 pi, or sorry, not 2 pi, just 2, okay, which would imply that b is pi. If you're wondering where I've been getting this from, we'll think about, remember, we used to say that the period was equal to 2 pi divided by b. So if I plug in 2 for the period, solve for b, okay? So final answer, sine of pi x minus 1, and cosine of pi, quantity x minus 1/2 minus 1. Good job.